Welcome to solverfy.
So to answer this question, I've put our pH up here as 9.5, and the concentration of the base we find is 1.05 molar. The concentration of the acid, its conjugate acid, is 0.75 molar, and the volume we are working with is 0.5 liters. So I put up the Henderson-Hasselbalch equation up here for us to reference because the first step is to find the pKa. And so if you rearrange the equation, it will be pKa equals pH minus the log of the concentration of the base over the concentration of the acid. Okay, so we just plug in the numbers. pKa equals 9.5 minus log of 1.05 molar over 0.75 molar. Okay, and you plug that in your calculator and you'll find that the pKa equals 9.35. Okay, and we'll need to remember that for the future because we will use that again. So the next step here is to find the concentration of the hydronium ions in solution, or the hydrogens, the positive hydrogens that the hydrochloric acid puts into the solution. And the way you do that is by just taking moles over the volume, which equals molarity. It's pretty straightforward there. So we added 0.005 moles of hydrochloric acid to 0.5 liters. Oh, that's a weird 5. And that equals 0.01 molar. Okay? Now what we do is we take that, and I've already prepared this, we make an ICE table, and the I stands for initial, the C stands for change, and the E stands for equilibrium. So we go back here, it equals 0.01 molarity, so we put that in here because that's the initial. Okay, and these are all in molarity, and that makes it easier for our units. So if we subtract 0.01 molar from our base, because it's an acid, so it takes it away from the base, this is also subtracting from the hydrochloric acid, but it's adding 0.01 molar to the acid. And so that brings our equilibrium to 1.04 because you just subtract that. This one is 0, and this one equals 0.760 molar. Okay? So now that we have these values, these are the concentrations of those. So now we can put that back into our Henderson-Hasselbalch equation to find the pH. Okay? It's pretty cool how we can do this. So remember back here, the pKa is 9.35. So we'll put that in. And then we'll add the log of this concentration is 1.04. Okay, and that's the base, so it goes on top. And this concentration is 0.76. That's the acid, so it goes on bottom. And we just plug it into our calculator again. We find that the pH is equal to 9.49, which is not a big difference from 9.5. Again, 0.005 moles of hydrochloric acid will not change the pH too much, especially in a buffer. That's the purpose of a buffer. But there you go, that's the answer to that question.